Assalamu alaikum, my dear student. Today our topic it is Euler's method and Taylor series method. Today, now student, what is Euler's method? When the initial value problem of ODE, when we solve the ordinary differential equation with the help of given initial condition, when we find the ordinary differential equation with the help of these methods, Euler's method and Taylor series method. So now we will talk about first one is Euler's method. Student, it is one of the oldest and simplest method of finding numerical solution of ODE. ODE means, student, when the order of differential equation it is 1 and degree it is 1, that's why we call it ordinary differential equation. Euler's method and Taylor series method, both methods are to find the numerical solution of first order differential equation or first order ordinary differential equation when you have initial condition if you have given. So now student, in this method we approximate a curve in a small interval by straight line. You can see that if we consider on x-axis it has 3 points x0, x1 and x2, then we will consider and draw a straight line. These are the ordinate values y0, y1 and y2. If this point we consider as it is as x0, y0, y is equals to f of x, it is a curve. So these are the straight lines when formed. These straight lines called a tangent. So in this method, student, we approximate a curve in a small interval by a straight line. If we consider at x0, y0, the equation of tangent will be, with the help of equation of tangent, as you know that y minus y0 dy over dx at x0, y0 into x minus x0. This is the equation of tangent at x0, y0 when we consider here. In the next step, student, you know very well dy over dx is equals to at x0, y0. If we write in this way, f of x0, y0 and x minus x0. So in the next step, if we will determine the value of y minus y0 if we transfer on the right hand side. So y is equals to y0 plus f of x0, y0 into x minus x0. Similarly, if we find out the next value at x is equals to x1, so then y1 is equals to y0 plus f of x0, y0 into x1 minus x0. So as you know that what is h? X1 minus x0, it is called h. We find the difference between two values. So we represent here, it is h. So in the next step, we will write here y1 is equals to y0 plus h times f of x0. Similarly, for y2 is equals to y1, previous we find the value y1 plus h times, h is the size of interval, and at x1, y1, we find the value of the function. So it is in general, when we find the nth value, so the formula it should be y of n plus 1 is equals to y of n plus h times f of xn, yn, where n runs from 0, 1, 2, 3 and up to so on. So student, this formula is known as Euler's method. So now we consider an application about the Euler's method. When we applying, the student find y for x is equals to 0.1 and dy over dx, which is equals to y minus x over y plus x. It is a function. Dy over dx represent here, student, it has first order and first degree. So that's why this equation is called ordinary differential equation. This is initial condition. It means it is x0 and y0. So first we write here, what is x0, y0? x0 is 0, y0 is 1. So the value of x you have given a student, it is 0.1. It means y is required at this point. So if we add both of them, student, x0 and x1, x, it means we find the h is equals to x0 plus x over 2. It means 0 plus 0.1 upon 2. It is called 0.05. So we will determine with the help of these two values, h is called 0.05. After find the value of h, student, we consider the first point. Now we write the formula applying Euler's method. Applying Euler's method. What is Euler's method? You know very well, yn plus 1, which is equals to yn plus h times f of x and yn, where n runs from 0, 1, 2 and up to so on. So student, when we consider start from 0, 1, it means the initial condition. So we will consider if we put here when n is 0 in this equation, if we write the name of equation A, when n is equals to 0 in equation number A, then A implies that y1 is equals to y0 plus h times f of x0 y. So as you know, student, what is f of x? F of x y is equals to y minus x over y plus x. If we find the value at x0 y0, x0 y0, student, you have given it is 0 1. So when we put here 0 1 plus 0 and 1 minus 0, the answer it is 1. It is y0, so y0, it means 1 minus 0 upon 1 plus 0, it means the answer it is 1. So therefore y1 is equals to y0 is 1 plus h is 0.05 and the value of the function at this point it is 1. So the answer it is 1.05. Now similarly, student, when n is equals to 1, if we put here again in equation number A, we get, so then equation number A, y2 is equals to y1 plus h times f of x1 y1. What is x1 y1, student? x1 is equals to 0.05 and y1 is equals to 1.05. You have determined. So student, x1 y1 when we put here in the given function. So first we write a function at f of x1 y1 which is equals to f of 0.05 1.05 which is equals to y minus x and y plus x divided by 1.05 plus 0.05. So the answer it is 0.9090. So the value of the function is spent. We will find with the help of calculator. Then again, therefore, y2 is equals to y1 is 1.05 plus h is 0.05 and the value of the function it is 0.09. We put here 0.909. Mistake. So when we applying calculator and find the result, it is 1.0955. So it means student y2 is equals to 1.0955. So what is x2? It means x2 is equals to x1 plus h. x1 is 0.05 plus 0.05. It is x2 is equals to 0.10. So after finding the result, we will show the result in this form, student. So make a table at the end of the result. When x is 0, y is 1. When x is 0.05, y is 1.05. When x is 0.1, it means, so y2 is 1.0955. This is your final result. When we are applying the Euler's method, it is called x0, x1, x2, y0, y1, y2. Now we consider, student, when we learn about Euler's method, after that we will start the new method, what is Taylor series method. Now consider the first order differential equation, dy over dx. It has one order, 1 degree. It means ordinary differential equation. It has first order differential equation. That's why we call it equals to dy over dx is equals to f of xy with initial condition y of x naught is equals to y naught. So we can expand y of x as a power series in x minus x naught in the neighborhood of x naught by Taylor's theorem. So it means we are applying here, student, Taylor's theorem. Taylor's theorem says that y of x is equals to y of x naught plus y prime of x naught into x minus x naught in plus sign y double prime of x naught divided by 2 x minus x naught whole square plus y triple prime x naught divided by 3 factorial x minus x naught whole cube plus n up to so on. So student, what is x minus x naught? X minus x naught represent here of h, which is equals to h. It means the size of a class interval. So if we find the value of x from this equation, so x is equals to x naught plus h. So student, when we put here x minus x naught, it is h. So the equation of, so the Taylor series equation in this form, y is equals to y of x naught plus h times f of x y prime of x naught plus h square upon 2 factorial y double prime of x naught plus h cube over 3 factorial y triple prime of x naught plus up to so on. Or if you write a student at x naught y naught, if you write only, because we have already known that y is a function of x naught, so this function which is equals to y naught, which is equals to y naught at x naught, at x naught, it means y the value of y is at origin. So the formula, it should be in this form. So y is equals to y of x is equals to y naught plus h into y naught prime h square upon 2 factorial y naught double prime plus h3 over 3 factorial 1 y naught triple prime. After find the first function value, then if we consider student x1 is equals to x naught plus h, then y is equals to y1 is equals to y of x1. Y is a function of x1, so this value is called y1, y naught plus h times of this. Similarly for the, if you find y2 at x2, so the function it is y1 plus y1 prime, y1 double prime, and y1 triple prime, and up to so on. Similarly, if you find the result, the nth function, so yn plus 1, which is equals to yn, it is yn plus 1, it is yn plus each value is called yn. So when we put here, the condition shows that when n is equals to 1, 2, 3, then we put here and find the different values when you have given. So this formula is known as student Taylor series formula. Now we solve a problem about the Taylor series method where we applying to solve dy over dx. It is first order differential equation. It is also known as ordinary differential equation because if the differential equation, if it has one order and 1 degree, that's why this equation, differential equation, is called ordinary differential equation. So the differential equation, if you have given y is equals to x plus 1, student, you have given an initial condition, it is x naught, it is y naught. Find the value of y at x is equals to 0.1 and x is equals to 0.2 by Taylor series method. So student, first we write the x naught and y naught. What is x naught? X naught is 0, y naught is 1, and write a function. After that, y prime is equals to dy over dx, which is equals to x plus y. After that, we will find the derivative, second derivative equals to, with respect to x, it is 1 plus y prime, and if you find the third derivative, it means it is y double prime, the derivative of constant, it should be 0. So if you find the value of this at this point, so y prime of 0, 1, it is equals to 0 plus 1, which is equals to 1 at y double prime 0, 1 at the given initial condition. Student, we will find the values. Y double prime is equals to 1 plus y prime, it is 1. So 1 plus 1 is 2. And y triple prime of 0, 1, which is equals to y double prime because it is 2. So when we find this one, find the derivative and add this at the initial condition, we will find all these values. Then we apply Taylor series method. So when n is equals to 0, and n is equals to 0, by 1 is equals to by, and n is equals to 0, in Taylor series formula. So student, y1 is equals to y naught plus h times of y naught prime plus h square upon 2 factorial y naught double prime plus h cube over 3 factorial y naught triple prime plus up to so on. At the end, because it has 3 derivatives, so we will stop here. So what is y naught? Y naught is 0, y naught is 1. h is point. What is h? If you find the value of h, you have given a student 0.2 minus 0.1, it means 0.1. So h is 0.1. H is 0.1. So we put here 0.1. Y naught prime it is 1 plus 0.1 square over 2. 2 factorial it is 2. Y naught double prime it is 2 plus 0.1 whole cube divided by 6. 3 factorial it is 6. And y naught double prime, triple prime it is 2 because they are equal. So if we find with the help of calculator, student find the result. What is y1? It is 1.1103. So now if we find that x2, it is 0.101. So when we consider at x1 y1, we will find x1 is 0.1, 1.1103. We have find in the previous step, and h is equals to 0.1. Then we will determine, student, with the help of these values, we will find and y2. So it means what is y1 prime is equals to, if you know that, x1 plus y1, which is equals to 0.1 plus 1.1103. If we find with the help of calculator, it is 1.2103. Now y1 double prime, which is equals to 1 plus y1 prime. What is y1 prime? Y1 prime we will find 1.2103. So 1 plus 1.2103, which is equals to 2.2103. And the last value is y1 triple prime, which is equals to y1 double prime. So it means 2.2103. After find the derivative with the help of this x1 y1, we will find the next value y2. So again we applying when n is equals to 1 in Taylor series formula. Taylor series method. So student, we will put here y2 is equals to y1 plus h times y1 prime plus h2 upon 2 factorial y1 double prime plus h cube over 3 factorial y1 triple prime, then stop. So what is value of y1? Y1 is 1.1103. We have find in the previous steps what is h. H is 0.1. Y1 prime, student, it is 1.2103 plus h square upon 2 means 0.1 square upon 2 factorial means 2. Y1 prime it is, y1 double prime it is 2.2103 plus sine 0.1 whole cube upon 3 factorial means 6. And we find here in the previous step 3 factorial, which is equals to 6 into y1 triple prime, it is 2.2103. After putting all the values and applying calculator, students, y2 is 1.2427, 1.2427. So therefore, similarly, if we apply the condition similarly, if we applying the condition and put n is equals to 2, so what is y3? Y3 is equals to 1.2338, which is called y of 0.2. So the answer it is student 1.2338. So student, after that we will make a table. What is x? X is 0, y is 1, x is 0.1, and x is 0.2. At 0.1 is 0.1103. At 0.2 it is 1.2338. So thank you very much. I have completed my topic. तो स्टूडेंट आज हमने दो मेथड स्टडी किए, टेलर सीरीज मेथड और and Euler's method. Both are applying when the ordinary differential equation to solve the ordinary differential equation with initial condition at y of x naught, which is equals to y naught. So thank you very much. Take care. God bless you. Allah Hafiz.